Assalamu alaikum. First of all, I would like to thank the organizers for providing me this opportunity to present my research at this international forum. I'm Saliha Karamat from the Department of Pharmaceutics at Government College University, Faisalabad. And today I will be presenting my work on the topic Design and Evolution of Silica-based solid dispersion containing naproxen for rheumatoid arthritis. On focusing on this, I explain its objective, its problem, methodology, and its significant finding. So let's begin. So the topic of my presentation is the design and evolution of silica-based solid dispersion containing naproxen for rheumatoid arthritis. The contents of my presentation is the introduction, its aim and objective, problem, methods, and its results, and conclusion. As for this, many drugs have low water solubility, which make them difficult to formulate into the effective dosage form. Because of this, high dosage is required to achieve its therapeutic effect on the body. Therefore, improving the dissolution rate of such drug is very important as it can enhances the oral bioavailability and also reduces the dose required to produce its therapeutic effect. An effective approach to overcome this problem is the solid dispersion. In this method, drug is dispersed in a non-reactive carrier as in the solid dosage form. In this solid dosage form, that will increases its solubility. Several studies demonstrated that the solid dispersion is very important or enhances the solubility and bioavailability of such poorly water insoluble drugs. So this approach plays an important role in the improving drug performance. So, the aim and objective of my presentation is that to develop the ternary solid dispersion of naproxen using polymers with the non-ordered mesoporous silica that will improve its solubility, bioavailability, and also reduces the gastrointestinal injuries, and to develop the binary solid complexes with the different grades of silica such as cellulite 244Fp, cellulite Al1Fp, and cellulite XTP3150, and to develop the ternary solid dispersants with the different polymers like polexamer 188, eudragate L100 with the non-ordered mesoporous silica of cellulite 244Fp. I use cellulite 244Fp as it increases the solubility as compared with the other grades of the silica. And next is the problem statement of the drug. The problem by which I study this is that naproxen is the non-NSAIDs that is from the propanoic acid is used to treat the dysmenorrhea and rheumatoid arthritis. But the prolonged use of the naproxen may cause the gastrointestinal injuries and the inflammation into the joints. Naproxen belongs to the family of BCS class 2 system. Drugs having these are poor aqueous solubility and high permeability. My innovation of this study is that to improve the naproxen solubility and bioavailability in order to produce the strong anti-inflammatory effect and to reduce the gastrointestinal injuries. Next is the methodology of the binary solid dispersion, in which I dissolve the naproxen into the ethanol as it is insoluble into the water, and then placed it into the glass pestilent mortar and added the solenoid at 300 rpm and 50 degrees centigrade. I placed it into the magnetic stirrer for 1 hour. After 1 hour, I removed it from the magnetic stirrer and placed it into the hot oven and for overnight drying. After that, I collected its powder. Then the general methodology for the ternary solid dispersion is that I dissolved the naproxen into this ethanol and added the my polymers like polexamer 188 and eudragate L100, and by its complete dissolution I added rpm and 50 degrees centigrade, and after 1 hour I removed it from the magnetic stirrer and placed it into the hot over air dryer for overnight drying, and after that I collected its powder. Then the composition of the binary solid dispersions, I used 3 different grades of silica with the different concentration. My formulation F1 Soilite 244 1:1 is used as the optimized formulation as the solubility of this formulation is maximum as compared to the other derivatives of this. Then the composition of ternary solid dispersion, in which my formulation F13 and F17 shows the greater solubility as compared to the other derivatives of this. Then the results are entrapment efficacy and the solubility of the binary solid dispersion, in which in the solubility in distilled water pH 1.2 and pH 6.8, the solubility increases and the entrapment efficacy is also maximum into the formulation F1. Next is that the entrapment efficacy and the solubility of ternary solid dispersion, in which my formulations F13 and F17 also shows the solubility in distilled water and pH 1.2 buffer and 6.8 buffer solubility increases and the entrapment efficacy is also increases. That shows in which I characterize these formulations and for further studies. Next is that the in vitro dissolution studies at pH 1.2. As time passes, the release of the drug in the formulations in my formulation F1, F13 and F17, the release of the drug is more as compared to the pure drug. And in vitro dissolution studies at pH 6.8, it also shows us that as time passes, the release of drug in formulations F1, F13 and F17 is more than that of the pure drug. Then the characterization FTS shows that the pure drug absorbance and the formulation F1, F13 and F17 absorbance, there is not much differences. It shows that the chemical nature of the drug is not denatured, and the slightly change in the absorbance shows that there is a hydrogen bonding between these that can prevent it from recrystallization. The next is the SEM analysis. In this, the pure naproxen shows the smooth and crystalline structures shows, and the formulation F1, F13 and F17 shows the shorter and irregular structures. That shows us that the pores are in which the naproxen is embedded into the pores of the silica xylite. Next is the effect of gastroprotective in vivo. In this, the control group shows no gastric ulcers, as there is no injection of pure naproxen or any other formulation. And pure naproxen F1 formulation and F13 and F17 formulation shows that the circle shows there is a gastric lesion into the stomach, and my formulation F13 and F17 shows is less gastric lesion that can shows that there is the effect into the uh, formulations. Next is the gastric lesion, as the F13 and F17 shows less gastric lesion as compared to the pure naproxen. Next is the evolution of anti-inflammatory activity. It shows that the anti-inflammatory inhibition is reduces into the formulations F13 and F17 that shows its effect. In this, there is a 6 photographs of the paw of rats that shows that the inflammation reduces as time passes. The serum interleukin 6, that is the biomarker that shows us that the disease group is produces or induce the inflammation, and in the formulation F17 and F13 shows us that in the inflammation is reduces. In TNF alpha measurement, it also shows us that the inflammation is reduces in the formulation F13 and F17. And conclusion, I use two carriers to utilize to improve the solubility, dissolution rate, and bioavailability of the drug naproxen. TSD is ternary solid dispersion is shows more or enhanced bioprotective and anti-inflammatory effect as compared to the BSD. So the polexamer 188 and Judragit L100 are used to reduce the stomach irritation that caused by the NSAIDs. Thank you very much for your time and attention. It has been a great honor to present my work here. I truly appreciate the support of my supervisor and the opportunity provided by the organizer. I look forward to your queries. Thank you.